Guys, Matthew here again with this week's shared problem. So I noticed over the reading and over the comments, there's been a lot of discussion about dosing with patients and weight-based dosing and you know how important it is. And I'm actually really excited because that's kind of what I do as a pharmacy technician. And you know, one of the things that I personally like to do in my profession is to figure out weight-based dosing and then take it a step further based on the particular drug and the concentration that I get with it. You know, how much of a drug that I'm going to be giving to a patient for a particular disease state in order to achieve the desired therapeutic effect. I know, I'm a nerd, right? So let's just get into it. So let's say that we have a patient that comes in and presents themselves with acute bacterial otitis media. So one of the drugs of choice that we're going to use to treat that is going to be ceftriaxone, which is an injectable cephalosporin antibiotic. And so we go ahead and we want to make sure that we maintain weight-based dosing or we're as accurate as possible by using weight-based dosing. So let's say that our patient is 190 pounds. And that's fine, but the thing is weight-based dosing is based off of the metric system kilograms, so we need to be able to convert this. And so we want to know how many kilograms our patient is going to weigh if they weigh 190 pounds. So we know that for every 2.2 pounds, that is going to be equivalent to 1 kilogram. So at this point, we could just go ahead and cross multiply and divide, and we end up with 2.2x, because we're multiplying the 2.2 times x, and that is equal to 190. And in order to isolate the variable, here's where the division comes into play. So we're going to divide by 2.2 on each side, and we end up with x is equal to 86.36 repeating, but we're just going to go ahead and cut it off and round to the hundreds place. And that is what our patient weighs, is 86.36 kilograms. Now, if we take a look at the standard dose for acute bacterial otitis media, one of the choices is that we can inject intramuscularly just once, and the weight-based dosing for that is 50 milligrams per kilogram. And so if the dose is 50 milligrams for every 1 kilogram that our patient weighs, and our patient weighs 86.36 kilograms, then the question becomes, how many milligrams are we wanting to give our patient? So again, we just do the same thing. We cross multiply and divide. We end up getting 1x or x. So the variable is already isolated, and we multiply 86.36 by 50, and we get 4,318 milligrams for the dose for a patient. So let's say we go ahead and we want to go ahead and administer the 4,318 milligrams. So we take a look at our shelves, we find the ceftriaxone that we want to use, and we have to determine what kind of diluent we are going to reconstitute this particular medication with. Usually it's, for this drug, it's sterile water for injection, normal saline or dextrose 5%, which is otherwise known as D5W. So we can go ahead and use either one of those three solutions in order to dilute or reconstitute our medication. The resultant concentration that we're going to get for that is depending on how much drug is in the vial and how much of our diluent we use to reconstitute it, but it's typically acceptable to be in a range for intramuscular injection at 250 to 350 milligrams per milliliter. Since we're going intramuscularly, it's really a good idea to get the strongest concentration that we can get so that we inject less volume, because it's going into one of the large muscle groups, and injecting liquid straight into a muscle group is not a pleasant experience. I can vouch with my own personal memories of that. So we want to give 4,318 milligrams, and let's say we reconstitute our Rocephin to 350 milligrams per milliliter. Well, I want to give 4,318 milligrams, so how many milliliters am I going to inject into that patient? And so again, cross multiply and divide, you end up with 350x and that is going to be equal to 4,318. Again, we want to isolate the variable by dividing by 350 on both sides. And that leaves us with x is equal to 12.337, and it just keeps going. But we're going to go ahead and round to the hundredths place, and so x is going to be equal to 12.34 milliliters. And that is going to be the dose, or the amount of volume that we're going to have to withdraw from the vial and inject it into our patient. So hopefully this has been helpful to you to maybe see a little bit of insight into what it is that we're doing in the world of pharmacy to make sure that our patients are safe. All right. If you have any questions, post them below. Thanks.